All right, so we're going to spend the last two classes in this chapter talking about parallel and perpendicular lines. That means that Monday we'll have a quiz, a second quiz on chapter 7. That's going to include what we're learning about parallel and perpendicular lines. Tomorrow I'll give you your unit review to start working on over the weekend because you guys are writing your next unit exam on Wednesday. Okay, so next Wednesday will be your next unit exam that covers chapters 6 and 7. So quiz Monday, unit exam on Wednesday. So let's look at parallel and perpendicular lines. This first page, first question asks us to graph both of those lines on the grid provided. You will note that both of those are in slope-intercept form. Remember, slope-intercept form is y equals mx plus b. You've got to have positive y by itself on one side, everything else on the other. Normally you're going to have two terms on the other side, one that has an x, one that doesn't. The term that tells you the x term tells you what the slope is. The number in front of x. The coefficient is what m is. That's the slope. And the term that doesn't have the x, the constant term, that tells you the y-intercept. That's what b is. So we've been talking a lot about this form of a line and what it is used for. So you should all know this by now. I shouldn't have to keep reminding you about this. We've been talking about it so much. So slope is m, the number in front of x. The constant term tells you the y-intercept, which is where the graph crosses the y-axis. Okay? And both of these lines are in slope-intercept form. They're in y equals mx plus b. You have positive y by itself. The y-intercept of the first line is -1. The slope is 2/3. So we start at the y-intercept in -1. Remember, that's where the graph crosses the y-axis. And then from there, you can rise 2 and run 3. Rise 2 and run 3. We can rise 2 and run 3 again. Or we could rise -2 and run -3. Rise -2 and run -3. Both of those will work. You see that all of these points line up, and we can now draw a line going through them. So there's that line. And we always put arrows on the ends because the line continues on in that pattern forever. The second line, the equation is y equals 2/3 x minus 3. So that, again, is in slope-intercept form. It has a y-intercept of -3, and the slope is the same. It's 2/3. You're going to rise 2 and run 3. Rise 2 and run 3. You could also rise -2 and run -3 if you want. All those points line up. And so you can draw the line going through them. And once again, we always draw arrows on the ends because the line goes in those directions forever. So part A says, what do you recognize about these lines? And what you should recognize is that they are parallel. They go at exactly the same angle. They will never cross. They will never intersect. And we know that's true because their slopes are the same. That's what we notice about the equations. The coefficient of x is the same for both equations, 2/3. And that tells you the slope. Okay, so their slopes are equal. That's what we notice. And remember, slope tells you what angle the line is going at. If the slopes are the same, they're going at the same angle. Sorry? Okay, so it makes sense that the lines will be parallel because their slopes are the same, which means they're going at the same angle. So obviously, you can determine whether lines are parallel by finding their slopes. You can put them in slope-intercept form, compare the slopes. If the slopes are the same, the two lines will be parallel. They're going at the same angle. They'll never cross, never intersect. So looking at these next examples, they are not parallel. Now you look at the slopes. The first slope is 3/4. The second one is negative 4/3. Not the same, so they're definitely not parallel. But let's graph them and see what they do look like. So the first line, again, is in slope-intercept form. The slope is 3/4. The y-intercept is -2. That's where we start, y-intercept, where the graph crosses the y-axis. And then we're going to rise 3 and run 4. We can rise 3 again and run 4 again. Or you could rise -3 and run -4. And that's really all we have room to do for this line. But we've got lots of points that line up there, so we can draw our line going through all those points. And there's the first line. Our second line has a y-intercept of +3. Again, it's in slope-intercept form. The y-intercept is +3, and now the slope is -4/3, which means either the rise or the run is negative, not both, because if you make them both negative, you'll have a negative over a negative, which will be positive. So we can rise -4 and run 3. We can rise -4 and run 3. Or we can try and run +4, 1, 2, 3. We're going to have to kind of estimate where that is because we run out of room. But when you rise -3, that point lines up with the other ones that we have there. So we can draw our line going through those points. And this is what it looks like. Again, we put arrows on the end. And once again, these lines are not parallel, but what you should recognize is that they do intersect at 90 degrees. They are perpendicular lines. They intersect at 90 degrees. They form a right angle. So these are perpendicular lines. And if we compare their slopes, there is a connection there. The first slope is 3/4. The second one is -4/3. So two things have happened there. The first is that the slope has been flipped over, which is called the reciprocal. The second thing is that the sign changed. The first one has a positive slope. The second has a negative slope. We describe those by saying the slopes are negative reciprocals. The negative part tells us that the signs changed. The reciprocal part tells us that it flipped over. So the conclusions we make here is that parallel lines have equal slopes and perpendicular lines have slopes that are, again, negative reciprocals. Which means, again, two things are happening. The sign is changing and the fraction is flipped over. So you might be asked, you might be given two equations, say they're in general form, and you might be asked to state or determine, are the lines parallel, perpendicular, or neither? You're going to find the slopes of the lines to determine that. Put the equations in slope-intercept form. If the slopes are the same, they're parallel. If the slopes are negative reciprocals, that would tell us that they will be perpendicular. They'll cross at 90 degrees. Any other situation where the slopes are different, they're going to cross, but just not at 90 degrees. Okay? So, again, We're talking about parallel and perpendicular lines. So we're going to identify two lines and determine whether they are parallel, perpendicular, or neither. We'll do some examples where we have to write the equation of a line using the coordinates of the point and whether that line is parallel or perpendicular to another line. So we'll see examples of all those. Again, parallel lines have the same slope but different intercepts. This includes horizontal lines that have a slope of 0 and vertical lines that have an undefined slope. Those are also parallel. Parallel lines are lines in the same plane that do not intersect. They have the same slope but different intercepts. Perpendicular lines, those are two lines that intersect at 90 degrees. The lines have slopes that are negative reciprocals of each other. Okay? So those top two graphs show two different sets of parallel lines. In the second situation, those are both vertical lines where their slopes are undefined. They're still parallel. These other two examples show perpendicular lines. The first line has a slope of -0.5, the second one positive 2, which is 2 over 1. The sign changed and the fraction flipped over. They're negative reciprocals of each other, right? This next graph shows a set of perpendicular lines. It just so happens that one of them is horizontal, the other is vertical. They are 90 degrees, but one slope is 0, the other is undefined. So they're not really negative reciprocals of each other. However, if we say that m1 is 0, you can say that's 0 over 1. And then you can still write the negative reciprocal for m2 as -1 over 0. You change the sign, you flip the fraction over, and anything divided by 0 is undefined. When you have a horizontal line, the line that's perpendicular, its slope will be undefined. Okay? Now there's another thing that's written down here at the bottom. m1 times m2, the product of their slopes are -1. That will always happen if lines are perpendicular as well. We say they're negative reciprocals of each other, they're slopes. The other thing that happens is that when you multiply the slopes together, you will get -1 as the answer, if the lines are perpendicular. When you multiply negative reciprocals together, the product of their slopes will be 0, or -1, excuse me. Okay, example 1 then. State whether the lines in each pair are parallel, perpendicular, or neither. What would you say the answer is to part A, Olivia? Are they parallel? Why not? Because their slopes are not the same, right? Both of those equations are in slope-intercept form. Y equals mx plus b. The slope for the first line, we'll call m1, is positive 3. The slope for the second line, m2, is negative 1/3. They're not the same, so they can't be parallel. Are they perpendicular? Keen. Give him a smack. Keen. You're drooling on the desk. You're not supposed to destroy school property. Declan, are they perpendicular? Why? If you flip the 3 over 1 and change the sign, it becomes -1/3. Right? So those are negative reciprocals. Remember the other thing, if they are perpendicular lines, if the slopes are negative reciprocals, when you multiply them together, you'll get -1. Remember to multiply fractions, top times top, bottom times bottom, and -3 over 3 is -1. These two lines are perpendicular. And there's a symbol for perpendicular lines. It's just basically drawing an upside down T. Right? The bottom is perpendicular to the line that goes up. So then we can use that to show perpendicular lines. The second set of equations, again, are both in slope-intercept form. You've got positive y by itself, y equals mx plus b. Brooklyn, what's the slope of the first line? And what's the slope of the second line? Is that right, Stanley? Yeah, they are both in slope-intercept form. Y equals mx plus b. M, the number in front of x, tells you the slope. So Keaton, are these lines parallel? You want to bet a pop on that? Are they parallel, Jan? Are their slopes the same? So they're parallel. These are parallel lines. The slopes are the same, which means they go at the same angle. And we can have a symbol for that as well, just drawing two little lines that look like they're going at the same angle. They are parallel lines. All right, looking at question C. Do we know the slope of line 1, Chloe? What is it? Right. That line is in slope-intercept form, so we know the slope of it is positive 2. Sal, do we know the slope of the second line? Why not? It's in general form, not in slope-intercept form. So Cheney, how do we put it in slope-intercept form? Got to get y by itself. Yes. Sure, you can do that if you want. So that'll give us 6x plus 3 on the left, and you'll get negative 3y on the right. Now what? No, just by negative 3. In the past, normally we kept the y positive, moved the other two terms over, but it doesn't matter. This will work if you do everything correctly. So on the left, 6 divided by negative 3 is negative 2x, plus 3 divided by negative 3 is actually minus 1. And on the right, negative 3 divided by negative 3, they cancel, you get positive y. So that's the same thing as saying y equals negative 2x minus 1. Emil, what's the slope of that line? Pardon? You want to bet a pop on that? Can you not see that? What is the slope of this line? I'm asking, can you see the board, or what's the slope of that line? Negative 2. Are they parallel, Keen? Are they parallel? So you're saying you don't know if they're parallel or not? You think they're parallel? You can bet a pop on that? He doesn't need any help from you guys. I just want myself a pop. Is positive 2 the same as negative 2, Keen? No, they're not parallel. Okay, I'm going to give you a chance to win it back here, Keen. We'll go double or nothing. So instead, they're not parallel. Are they perpendicular? No? That's your final answer? Are we betting double or nothing?
I don't know.
You don't want to bet double or nothing? You want to bet double or nothing? Okay. They're not perpendicular because they're not negative reciprocals.
Sid.
Yeah, you should have bet. You would have been even. Yes, Brock, question. By comparing their slopes. Both of these lines, we put them in slope-intercept form. Y equals mx plus b. That's right. If the slope tells you what angle the line is going at, that's what it tells you. If the slopes are the same, they're going at the same angle, they're parallel. If the slopes are different, they're going to intersect somewhere. But if their slopes are negative reciprocals, meaning you flip the fraction over and change its sign, if that happens, then they cross at 90 degrees. Any other situation, they're going to cross somewhere, but just not at 90. So those are only three things that can happen. Parallel, perpendicular, or they're going to cross somewhere, but not at 90 degrees. Okay? So these are neither. Now remember, the other thing you can do, if you multiply M1 times M2, if the lines are perpendicular, that product must be -1. In this case, it's -4, not -1. So this would be neither, which again means that they're going to cross somewhere, but just not at 90 degrees. So there's two things you can check for perpendicular lines. Compare them. If they're negative reciprocals, they are perpendicular. The other thing, multiply the slopes together. If that product is -1, they'll also be perpendicular. But if it's not -1, then it's neither. All right, so looking at this next one. Peyton, do we know the slope of that first line? What is it then? You better pop on that. That's good because you don't know the slope of the line just by looking at it because it's not in slope-intercept form. You need to get positive y by itself to put it in slope-intercept form. Okay, Peyton, so what would you do first? We want to get positive y by... Well, you could, but I think I would just subtract the x from both sides. Because you want to get positive y by itself, and the way it was originally, the y term is positive. So I think it's better to do it this way. Your way would work, but there'd be an extra step involved. So that leaves us with positive y on the left equaling 2 minus x, or negative x plus 2. And I wrote it like that because y equals mx plus b. Normally we have the x term first. That's why I wrote the x term first. Are we done, Stanley? Huh? What do we need to do? Yeah, what Princess said. Do we have... No, tell me what you're going to say. Don't be shy. Princess won't laugh at you. Do we have positive y by itself? So what do we need to do to get positive y by itself? Yeah, I think that's what you're going to say to begin with, weren't you? So now we have positive y by itself on the left. So that first term after the equal sign is negative x over 5, negative 1x over 5, or negative 1 over 5x. It doesn't matter that the y-intercept is also a fraction because we're not asked to graph this. We just need to know what the slope is. So Roddy, what is the slope of that line? Just negative 1 over 5. M is the number in front of x. So the first line has a slope of negative 1/5. Brooklyn, do you know the slope of the second line? And how'd you get that? Except that y is not by itself. Remember, you got to get y by itself to do that. So we need to do that. We need to get y by itself. In this case, because the 10y is negative, I would probably start by adding 10y to both sides. So that'll leave us with negative 2x on the left equaling positive 10y on the right. Are we done, Sophia? Do we know what the slope of this line is? Do we have... No, because why? We have to get rid of the 10. We're going to have positive y by itself. So we would divide both sides by 10. And on the right, the 10's cancels. 10 divided by 10 is 1y, or just y, equaling negative 2 over 10, which is negative 1 over 5x. And that's the same thing as saying y equals negative 1 over 5x. So Kai, what's the slope of this line? What's M2? Yep. So are these lines parallel? Pardon? Because both the same slope. The slopes are the same. They're both negative 1 over 5. That means these lines will go at the same angle. These are parallel lines. Their slopes are the same. Keaton, do we know the slope of the first line? Why not? Right. So how do you do that? Yep, I would subtract 2x from both sides. So that's going to become a negative 2x on the right, and I'd put that term first, because normally we write them in y equals mx plus b. The x term first, the constant second. Yes? What? You can't see that?
See that?
You can see the black, right? Just not the red, or whatever color it is. Is it? There, you guys now know a very, I have a disability, okay? Don't make fun of me. I'm colorblind.
Oh, no, you're not.
I am. I am colorblind.
What color is it?
I would say it's like a gray.
It is a gray.
Okay, that's just a guess. It might be. Can't argue with you. And here you guys thought I was perfect in every way. Turns out I have a disability. I wonder if I can get some government funding for my disability. Probably could, yeah. Are we done? What do we need to do now? By? Yeah, all the terms get divided by 6. So y will equal, on the right side, negative 2 over 6 reduces to negative 1 over 3x, minus 3 over 6 reduces to 1/2. Again, it doesn't matter that the y-intercept is a fraction because we're not asked to graph it. But we do need to know what the slope is. Kenzie, what is the slope of this line? Negative 1 over 3. Right? It's in slope-intercept form. Okay, second line. Do we know the slope of that line just by looking at it, Cheney? Do we know the slope of the second line just by looking at it? Because y is not by itself. How would you get y by itself? Cheney, how would you get y by itself? Well, we need to get rid of this minus 3x. That's what's hooked onto the y. Well, the opposite of subtracting 3x is adding 3x. Not just 3, but 3x. So that'll give us y by itself on the left. On the right, it's a positive 3x and a minus 8. The 8 is minus. That's not going to change. So what's the slope of this line, Peyton? Are these lines parallel, Chloe? Well, the first line has a slope of 3, the second negative 1/3. They're not the same slope. So they're not parallel. Are they perpendicular? Yes, they are. You see, the first slope is positive 3, which is the same as 3 over 1. If you flip that over and change the sign, you'll get negative 1/3. Also, if you multiply the two slopes together, You'll get negative 3 on top over positive 3 on the bottom. That is negative 1. Their slopes multiplied together do give you negative 1. So therefore, these are perpendicular. They are perpendicular lines. Their slopes are negative reciprocals. Okay, we're going to stop there for today. Actually,
No, we should continue. Talking about.
Who are you, my mom? That is my mama.
who's your mama?
Yeah.
Jan, that means you can spank her. You can discipline her.
It's okay, only
And she needs lots of